Hello, everyone, and welcome to our panel on SB 2030. Welcome to the 80% to zero carbon goal neighborhood. My name is Heather Hanson, and I'll be moderating our discussion today. Sustainable Buildings 2030 is a Minnesota state program designed to reduce energy use and carbon emissions in commercial buildings. The energy standard is currently 80% below that of an average building, with an increase to 90% in 2025, and reaches net zero by 2030. The updated process this year is designed to streamline the project team's experience and includes revised economic payback criteria for on-site measures and access to renewable energy credits. Our panel will discuss the recent updates to SB 2030 in the context of Marshall Avenue flats and early entry in 2020 to the current process. We will discuss the challenges and successes with the updated process so far, as well as how to leverage utility or state-sponsored energy efficiency programs in meeting a project's sustainability goals. We will also explore best practices to continue to make SB 2030 an active and valuable design process for both public-funded projects and voluntary enrollment. We have 4 panelists today. Keon Blasingame is an associate project manager and housing sector leader with LSC Architects Incorporated. He strives to expand equity and diversity in the field as a Minnesota Architectural Foundation board member, as an architectural youth program facilitator, and as a University of Minnesota STEAM program Intro to Architecture instructor. In the community, Keon lends both his time and leadership to several scholarship foundations, including the Jackie Robinson Foundation, U of M Kirby Puckett Scholarship, and the Clarence Wigington Minority Architectural Scholarship. Keon has a Master's of Architecture and Bachelor of Science in Architecture from the University of Minnesota. Patrick Smith is a Senior Research Fellow at the Center for Sustainable Building Research at the University of Minnesota and a Project Manager for the B3 Guidelines and SB 2030 program. His area of focus is development and implementation of sustainable building programs and multi-scalar energy use and carbon emission reduction efforts. His research experience includes building performance auditing, affordable housing sustainable program development and implementation, building performance benchmarking, and whole building lifecycle assessment. He teaches environmental technology in the undergraduate and graduate architecture programs at the University of Minnesota. Russ Landry is a senior mechanical engineer at Center for Energy and Environment. Russ plays various roles in field research projects and energy efficiency programs for commercial and multifamily buildings. He started at CEE in 1989, and since 2005, he has been increasingly involved in new construction projects through plan review, whole building energy simulation, and other technical support to design teams and to organizations charged with project oversight and verification. This includes leading the third-party technical review of projects against the Sustainable Buildings 2030 Energy Standard since the program's inception in 2009. Kris Kohls has been a product manager at Xcel Energy for over 20 years. She is responsible for managing and marketing energy efficiency services with an emphasis on driving the adoption of efficiency and sustainability practices developed specifically for the construction of commercial and industrial facilities. She holds a master's degree in marketing from the University of St. Thomas. Welcome, everyone. Our discussion today is broken into 4 segments: programs and project overview, how a project team can best prepare, common hurdles at design phase submission and tips for best practices, and key benefits of meeting SB 2030. We'll then open up at the end for audience Q&A. Pat, let's start with you. As a program manager for SB 2030, could you start by giving us a brief overview of the program, some highlights of the current process, and the most significant changes compared to last year?
Thanks, Heather. So you noted a little bit on the overall structure of SB 2030, but I'll start by walking through an overview of the program and providing some updates that we put forward when we moved the standard to 80% better in 2020. So to start, and taking a bit of a step back, SB 2030 is modeled on the National Architecture 2030 program, but customized and adapted to better fit both Minnesota's specific building stock and also developing it to be able to be implemented as a required program for state-funded projects. In this case, for this project, the City of St. Paul as a requirement for the City of St. Paul. The program takes a baseline at an average building in 2003 of the same program, of the same essentially operations characteristics as a participating building. We used that 2003 baseline as that was the year of a large comprehensive building energy use survey called CBEX. And every 5 years, the program moves to an increased reduction from that baseline. In 2020, this shifted from a 70% better to an 80% better baseline. So when we say 80% better, we're talking about 80% better from that 2003 baseline, from that 2003 snapshot of energy and carbon consumption. And this program fits within a network of related programs that we have in the V3 guidelines program. On the next slide, you can see where this fits. We've got V3 guidelines coming alongside SB 2030 and going through the design and construction phases, and then a suite of programs that are coming in also in the operations phase that include benchmarking, which picks up energy and water consumption data for projects that are up and running, and a couple of other elements of our program. The two main tools that we use for projects working through the SB 2030 program are the B3 guidelines tracking tool here shown on the left, and the energy standard tool that's embedded within that shown on the right. Looking specifically at the energy standard tool, what this does is estimate how much energy a typical or average building in Minnesota of the same program would be using back in 2003, and then taking a reduction from that based on what program year the building is required to hit. So to get this baseline right, we need some information about what the building's program is in order to capture the characteristics of that building. What characteristics of that building impact the energy use? Because we can't set the same target for a warehouse that we would set for a research laboratory. We want to be very detailed about how we're doing this target setting exercise. So this is things like ventilation need, process loads in a project. If your project has a more intensive schedule, that all comes into play when setting your energy target for a building. So this develops a very customized benchmark for projects, so you will know you'll be treating them according to their program needs are. And we need this kind of fidelity because there's some variation even within building types among what between what the different loads are going to be. We pick up this definition, this building characterization, in terms of what are called space asset areas, and those are large programmatic building blocks of the project. So instead of us requiring project teams to implement, particularly in an early phase, number of corridors, number of bathrooms, number of attendant mechanical spaces, we're asking for these large programmatic chunks of buildings. So you're going to have 20,000 square foot of office and 10,000 square foot of laboratory and a 2,000 square foot garage. That's the level of detail that we're having input at this into this characterization, which is sufficiently accurate to set a goal that the design teams can look to hit. So project's path through the program. So I want to move to the next slide. They start by taking their program and putting it into the that one. The projects start by taking their program and putting it into the standard tool and develop that initial energy target for their project. At an early phase, this is typically done with some of the tool defaults for different building types. So if you don't know specifics around what your process load might be for a project, if you don't know specifics around what your airflow requirements are, this is a pretty good first step to getting that initial target, so that the design team can start to come to an understanding around what the requirements of this program are going to entail, where they can look to find those efficiencies or renewable measures. So this initial energy standard is set with those early phase inputs. This is refined through the SD and the DD phase, and then the building team comes forward with a design simulation that documents how it's performing in comparison to those to that target. The CD phase, which we call the final design phase, project teams submit a final energy model, and we verify the inputs of that model. And we're modeling that. Or we're documenting that the projects are hitting their energy and carbon targets, and that the inputs between the energy standard tool, the inputs between the design simulation that they're coming forward with, and the inputs to the energy standard tool are all the same. So construction documents, energy standard tool, and design simulation. We're looking to match all three of those. And then once projects are in operation, this is tracking of the energy standard continues, where the project is held up against its design and construction phase energy standard to verify that it's actually achieving the level of performance that was indicated by the design team. One thing I'll mention here is that with the ability to tune those inputs into the energy standard tool, if a project shifts its operation and would have a justifiable reason to adjust its energy standard, that's something that we can capture with our program. So if a project adds a few hours of operation, that's going to be seen in the energy use, and we can pick it up in our program and our goal setting. And so that's something that's enabled by the tool set that we developed. Looking at the renewable energy options that are available for projects. So 80% better is a significant reduction from that 2003 baseline. It does represent a step above current code, and in some instances represents a step above what to be achieved with what we consider to be cost-effective measures. So projects that can show that they are exhausting the cost-effective measures available to them can look at other options for hitting their SB 2030 target. But I'll mention that projects need to look at cost-effective measures both on the efficiency side and on the renewable energy side before looking at offsite options. They'll do this evaluation based on a hierarchy of renewable energy generation, and so this can be done in the broader portfolio, which comes into play for state agencies that may have other areas in their portfolio that present a cost-effective development option. But borrowing that in portfolio options, the project may document compliance by procuring renewable energy credits, or RECs. These are often attached to utility products, and they give projects the ability to claim that they're using and sourcing renewable energy. What we did when we looked at what that hierarchy should entail, we landed on this definition from the National Renewable Energy Lab that looks at specifically a classification system for net zero energy buildings. And so what this is work to classify those net zero energy buildings based on where they're getting their energy. So that hierarchy is what you're seeing left on the left side of the screen here. So we're looking at the first three options under this hierarchy as being equivalent. So we've got efficiency measures, renewable energy sources that are being developed on site, and renewable energy sources that are being developed as part of a larger campus, which we're expecting to see most often occurring on university campuses that fall under our program. So those three options of the hierarchy need to be exhausted before moving to other options, and we do that based on a cost effectiveness test. So projects will step through this hierarchy of renewable generation options, starting with hitting their cost-effective maximum development on the green box to the left, and then setting what we're calling an on-site target based on what they can do with those measures. Then projects step to offsite options for the blue box, and barring any on-campus development options, they'd move to what you see in the red box to the left. So we're stepping through this hierarchy of renewable options in order to still hit those targets, hit that 80% mark. And so one other note for program updates as part of this move to 2020, this was one element that we put some development work towards, was developing this hierarchy of renewable approach and different options to make available for project teams to be able to hit these targets. We also looked at what our definition of cost effectiveness was. So our work from the state is required to consider cost effectiveness, and for that consideration to be evaluated in the same way that the utilities consider cost effectiveness when developing their incentive programs. The type of evaluation that's done for utility program development is more detailed than you'd expect one off project team to pursue. And so we needed to develop a way to proxy that cost effectiveness in a way that was understandable for design teams. And what we landed on that was looking at a group of around 120 buildings and looking at what measures based on a simple payback could be considered to be cost effective and could be considered to pass, particularly the societal test when looking at effective use of resources. And so that initial study by CEE landed on a payback period of 15 years or less, could be considered to be cost effective under this logic. That was done in 2009. And so that was the test that we had in operation for the first roughly 10 years of the program. In 2019, we updated that analysis to include and to update the carbon mix of the grid, because the grid has become much cleaner than it was in 2009 when we first ran this. And that landed simple payback as the current boundary of cost effectiveness as considered by our program. I'll note that 12-year payback window excludes incentives because that's the method that the utility program calculations use. You exclude incentives when you consider to be payback periods, and that includes incentives for utility programs that rebate. So when you're doing your calculations for this, if you're working through this, exclude your incentives when you're figuring out your payback windows. Additional program update is to hold renovations to the same standard as new construction. When we moved, we looked a lot at how far the code had gotten. It had surpassed where we were with SB 2030, so we were seeing some opportunities unmet. And looking through the database of projects that had previously gone through the program, we were seeing many of them were making it much of the way, sometimes all of the way, to the 2030 standard. And so with this additional ability to pick up offsite options, we moved the program to be able to pick that level of performance up for renovation projects as well. But I'll note here specifically, if a renovation project is looking to use that hierarchy of supply options to meet its standard, we are sensitive to considerations around durability and other issues that come up, particularly around historic building and particularly around historic masonry projects, where there's a limit to the amount of increased assembly performance that you can achieve because of these durability issues. And as a final note, I'll talk about a few alternative paths we have in the program. We have a small buildings path where we're still using the same overall structure. Where projects look to on-site opportunities before moving off-site, but then allowing this to be done with a prescriptive approach rather than going through a process of iterative energy modeling. We also approach for partial mechanical upgrades if only a limited amount of mechanicals are being modified. We have a wastewater treatment process, which looks a bit different because there are different opportunities in that sector and a different level of energy modeling that's typically performed. And then there's something that was sunsetted in 2020, and that's the cost-effective adjusted standard. So this was a process that has been now developed into setting this on-site target before stepping forward to off-site options. And so projects that started this schematic design prior to 2020 are still, a few of them are still working through this process. But from 2020 on, that's moved into setting this on-site target.
Great. Thanks so much, Pat, for that detailed review. Moving on to Russ, how do you approach your review of projects with the recent SB 2030 changes? Are there design aspects that you're focusing more on now?
Thanks. While the review process for the final design hasn't changed much, I'd like to say that it's more important than ever for project teams to make sure that they early on take a close look at making sure that they set an accurate SB 2030 energy standard, and also early on get a good indication of their early design energy performance to make sure that they have realistic expectations in terms of where they stand in comparison to the standard. It's like to point out for the projects that we've that have moved through the process and kind of completed the process in the last projects on average changed their SB 2030 energy standard value an average of 23% from when they first came in for our initial review compared to when they were finished their final review, and also their estimated design energy use changed by an average of 28% from what their initial early stage evaluations were, and then after going through the review process and updates, and also just design updates that were done during the time frame, they changed an average of 28%, and that's that's a pretty big changes in energy performance that you need to plan for in terms of trying to meet this energy standard. So I'd like to say, make sure you take a good look at that early on, and if you have any questions and foresee any issues in terms of meeting the actual standard, it's really important that you reach out as early as you can to Pat Smith at CSBR to kind of start the process of figuring out how much you can accomplish on-site versus off-site, and kind of what the items are to look at in terms of evaluating the on-site versus going off-site for cost effectiveness. Although at the final design phase, our reviews haven't changed much. We are trying to take a harder look early on for projects that do provide more detailed information early on. Now there's only one phase earlier where we do a third-party review of the SB 2030 standard, and that's at the D phase, and it's not required that you provide simulation documentation or detailed design data at that time, but to the extent that project teams do that, we will make the extra effort to do earlier reality checks on that end-to-end to help spot any potential issues in terms of consistency between how the standard is set and how the modeling is being done, and to try to help avoid any surprises later on, and kind of catch things early on and avoid issues as you go through the process later.
Great, thanks, Russ. Really good advice and good guidance to the teams. Keon, as a project manager and architect for Marshall Avenue Flats, could you tell us about the project and how it became involved in the SB 2030 program?
Absolutely. Thanks, Heather. The Marshall Avenue Flats is a 6-story, 97-unit multifamily affordable housing project located at the intersection of Marshall Avenue and Fry Street in St. Paul's Union Park neighborhood. This is a rapidly developing area of the city that's not so affordable, but has access to a lot of different amenities. So we saw it fit to look at affordable housing at this location to increase the housing stock within this community. Affordable housing projects seeking funding for various sources like LIHTC funding, low-income housing tax credits from the city of St. Paul. The St. Paul requires compliance with the city's St. Paul Sustainable Building Policy, which adopts the Minnesota Sustainable Building SB 2030 energy standards. So we received more than the $200,000 of funding that we were just talking about with Pat. So we were required to go through the process on this project.
Great, thanks, Keon. And Pat, is the Marshall Avenue Flats project, is that typical? What other common project types or motivations lead to enrollment in the program?
So SB 2030 is required for projects funded such as this one by the city of St. Paul. So we're seeing some similar projects working through the program. Some come in from scattered around St. Paul. We're seeing some come in from the Foresight development. Most of our work, though, is with state agencies and state general obligation bond funded projects. Those will look a little bit different than this because they have different opportunities. They may have a campus to work with. They may have more large scale renewable energy development to offset their increased demand as they're putting this building on the site. At the end of the day, though, the SB 2030 program are intended to engage projects in pursuing efficiency and offsetting demand. So bringing on, lowering the demand, and then to the extent the demand is coming on from this additional building to find a way to supply that with a decreasing carbon burden. So one of our challenges, I'd say, one of our goals in the program has been to adopt and to land the idea, land this concept across a lot of different building types and across a lot of different opportunities, which do vary between our work with the state and our work, in this case, with the private developers.
Great, thanks, Pat. And Kris, as the manager of Xcel Energy's Design Assistance Program, can you talk about how energy efficiency programs can assist projects in meeting the SB 2030 energy standards?
Sure, thanks, Heather. Utility energy efficiency programs are great resources for projects that are enrolled in the SB 2030 program, often providing services or incentives for installing energy efficient equipment. With EDA, we provide free energy modeling and consulting to identify and prioritize the cost-effective energy efficiency options. And rebates are available to offset the upfront cost of more efficient systems, driving down your initial investment and also allowing you to go beyond your initial plans. Energy models provide opportunities to reach new heights for energy efficiency and renewable penetration. They compare how combinations of building systems and components perform and allow you to decide on the best combination based on things such as project cost effectiveness, savings, initial expenditure, the incentives, a payback, or the energy use per square foot. And it really enables you to maximize your energy efficiency strategies at the lowest cost.
Thanks, Kris. Thanks, everyone. So let's talk next about how a project team can best prepare. Pat, what are some of the key tips you would like to pass on to design teams for beginning the SB 2030 process and preparing to navigate the program?
So with this move to the 80% better target, anticipating that a fair number of projects will want to pursue this process of setting this on-site target and then filling the remainder in with off-site opportunities. But to do so, we need to open a discussion early. This process works best when starting kicks off to get the folks at CEE and their technical expertise together with us at the CSBR to make sure that we're looking at a comprehensive list of strategies that are likely to fall within that cost-effective window, right now set at that 12-year mark. We're not looking for everything under the sun to be evaluated, but we're looking to get a list of things together that represent likely performance levels. So that's just a pitch to bring this conversation up early and as well effort for those projects in order to streamline their understanding about the level of performance, and also from the owner teams to understand what the offsite development options are going to need to be.
Okay, thanks, Pat. And Russ, can you add insight from the perspective of a reviewer? What do you think would be most helpful for a project team to know up front? Russ, you may be muted.
Thanks. I'd like to highlight a few things that are kind of emphasized by an acronym of 2 C's and an M. And the first two of those C's are consistency, and the M is for metering. And this graphic kind of emphasizes some of the consistency, and that as we review projects, it's very important that there's consistency between the SB 2030 inputs into the energy standard tool and what's being used in the design simulation. And some of the key areas there that we're looking for consistent is the programming, even things like square footage. We sometimes see inconsistencies in that, the space types, and also some of the assumptions for some of the key power energy indicators are the equipment power densities, are kind of the plug loads in the space. What's the fresh outdoor air flows that the systems are designed for, and the operating schedules, especially the schedules in terms of the lighting and the equipment plug loads. Those can have a big impact on the modeled energy use. And the other area of consistency is, if you look in the center and the right, is consistency between the design simulation and the construction documents. Again, we're looking at, besides square footage, space types, and outdoor airflows. We're looking at for consistency in the envelope, thermal performance, and the HVAC factors that affect power, in particular the fan power area where we sometimes see issues in terms of consistency between the simulations and the designs, and also just make sure there's consistency in terms of the efficiency, heating or cooling efficiency of that HVAC equipment. And also I'd like to point out the metering plan, just so people are aware of that early, that if there's special circumstances where you might need to look at sub-metering for plug vodes, and also if you're in a renovation or some situations where you need to add sub-meters in various locations, it's best to start on that early on and be aware of that. That again, the 2 C's and an M are the things to really be aware of early on.
Thanks, Russ. And Keon, did you feel your team was prepared? Were there any challenges in getting started, and what was the most helpful?
Thanks, Heather. Absolutely. No, I think one of our biggest challenges getting started was making sure that we understood how this new 80% EUI reduction target was going to impact our building systems, envelope, more specifically related to the MEP systems. It's a tall order to build to that sort of efficiency, if efficiency was your target alone. So I think one thing that helped us getting started was just trying to gather as much information as we could. We had a lack of information. What we knew was limited, and we knew that, for example, some of those paths to compliance or alternative paths to compliance were no longer available. That 15-year payback may have changed a little bit. I think when we had that kind of aha moment is when we engaged in the process with folks like Pat and all you guys, and we started to understand a little bit more that hierarchy of renewables chart, and basically essentially how that alternative path to compliance was sort of kind of baked into the process overall now. So we moved into it as we began to understand that and get more comfortable with that by looking at a number of different systems and engaging in the process a little bit more to look at those 3 sort of buckets, if you will, with on-site efficiencies to maximize energy efficiencies to meet that new payback period of 12 years. So looking at appliances, domestic hot water, envelopes and insulation, HVAC systems, lighting, and all that to really maximize those efficiencies as much as possible, and sell that to the owner too, as part of the process, because I know owners are always kind of keeping an eye on that bottom line too. So we want to be good stewards of their funds. Looking at on-site renewable energy sources as well, beyond just that 2% minimum that we talked about through the process, looking at other ways to achieve some of those goals to reduce that overall carbon footprint, like photovoltaic, things like that. Unfortunately, this project was a relatively tight urban site that limited those opportunities. And then looking into that third bucket, which is the off-site renewable energies, once we've kind of maxed out on the on-site efficiencies and renewables, looking at how we can obtain some of those renewable energy credits or RECs to build that into the model. And then looking at that as an opportunity to explore, is that a maintenance thing? Is it an upfront cost? How do you look at that and fit it into a pro forma? So that was some of the things that we attempted to navigate and understand early on.
Thanks, Keon. And Kris, how can energy efficiency programs be best leveraged in this early stage in the SB 2030 process?
Sure. Actually, the EDA's program enhanced track was specifically designed to support projects that were striving for SB 2030 or LEED or any other green certifications. And it evaluates more complex energy saving approaches just beyond the traditional methods. The value it brings in the early stages of the project include a review of the energy goals, as well as offering a series of in-depth studies all designed to maximize the efficiency of your project. And those studies include building massing to assess alternative massing and orientation options in order to maximize daylighting opportunities, building daylighting to compare alternate window size and placement options for daylight harvesting and sun shading, and then an HVAC analysis to evaluate different systems and zoning options. So as you go through the EDA process, an energy model is created, which enables you to see the breakdown of the energy use in the building. And then it provides you the opportunity to target the areas that have the most potential for savings. As in this example, while there's no ideal system for every project, an HVAC system is typically the one to offer the greatest opportunity for energy efficiency. And then along the way, along with the design team, the energy model is refined in real time. And this process helps identify the bundle of energy savings measures that will maximize the value of your investment.
Thanks, Kris, and thanks, everyone. So let's talk next about some common hurdles at the design phase submission and some tips for best practices. So Russ, let's start with you. What is the most commonly what is most commonly missed in submissions, and what tips can you give to help teams ensure that they're covering all of their bases the first time? Russ, you may be muted.
I'm going to go back to the same CCM, plus I'm going to add 2 more C's. Areas where we see issues in final design submissions are consistency between the energy standard tool inputs and the design simulations, all consistency between the as design simulations and the actual design itself. Those are, again, real critical things. And also metering, that there's a good metering plan, and especially when there's sub-meters involved, that metering plan needs to include detailed instructions and indications of how is data going to be captured from that sub-meter, and if there's calculations, if some sub-meters have to be added or subtracted from each other, that there's clear details so that 2-3 years down the road, when the project has energy data and need how it compares against the energy standard, they know exactly what to do with that metered data. And then the other, so again, the consistency and metered, and the other things I'm going to add are completeness of documentation, and that's both in the design process itself. So, for example, just the design is complete in terms of defining the energy performance of the different aspects of the design. So if there's a window, you don't just give an example product that you say it has a maximum assembly U value of whatever the value might be, and don't just and same for HVAC equipment, that you say exactly what efficiency is the maximum allowed, and not just say an equivalent to this product, because there's different aspects of performance of products, and just to make it crystal clear that something's not going to be acceptable unless it meets these specific energy performance levels. And also, so for our review, we want to see completeness of documentation, both complete drawings and specifications, and also complete documentation of the energy modeling, so that we can do a review of the inputs and compare that against the energy standard tool and against the design. And that's just, if submissions come in without all of that, then it just slows down the whole process. And the other C besides completeness that I'd like to add at this time is current, so that the things are updated to reflect the current design details. Modeling early on, and we'll make some assumptions, and then sometimes the final design, some of those values might change some in some of the areas where we see issues the most, where things kind of get updated, is what are the design outdoor airflows for the HVAC equipment? What's the fan power of the HVAC equipment? Might be different in the final design versus what was assumed in earlier modeling, such as would be done initially for through an EDA program, and also the lighting power densities. So again, the CCM plus 2 more Cs.
Thanks, Russ. So I've got consistency, metering,
Yeah.
completeness, and current. Correct? Excellent. All right. Those are really good tips. So I just wanted to kind of bake those back down again because that's really helpful for everyone. Thank you. And Pat, how about anything to add to that from your perspective?
I would just add to what Russ said, that the review does take some time, and we're working to our timeline for that. We're getting ahead of a little bit of a backlog in our review queue. But because this review takes time, and because this, as a project comes in, it slots into other projects that are in the review queue. With less complete information, that may require another round of questions or another 2 rounds of questions, which you like to avoid. And so that just stacks time on the process and pushes back the thing we're all chasing, which is this understanding about what the level of performance is going to need to be for the project to be able to hit the 2030 target and hit their on-site target, and to kind of step through the process. I will say from our end, in order to assist with this streamlining, and because we're asking for projects to come forward with this strategies that will be evaluated, we're looking to develop specific lists for different building types, so we can at an upfront meeting provide what we'll be asking for a multi-family housing project, for example, or for an office project, or for a university building, so that we can avoid some of that initial back and forth, and we can give project teams an earlier understanding about what the universe of things that we think are likely or potentially going to fit within that window. Again, if they're pursuing this on-site target setting path through the program. So yeah, but the overall pitch is to get your submissions in order and with all the level of appropriate detail, but also to reach out and have discussions early. I mean, we're a local program with local resources, and we're available to assist and available to work through projects and answer questions as they come up.
Thanks, Pat. And I think that idea of those specific building type guides will be really helpful to teams as they work through that. I know Marshall Avenue Flats had some upfront assistance with that I know was really helpful. So not to jump in there, but Keon, did you face any of these challenges then on Marshall Avenue Flats? And then how did your team handle them, and how might you approach it differently a second time, or would you approach it differently?
Yeah. I think I don't think I would. I think we had the right team, and I think that's key. Making sure that you've got the right folks kind of in the loop and helping you out through this situation. So we had great consultants helping us through the process. I think one of the challenges that we faced, and again, I'll repeat it, was coming up with those strategies initially. So Pat just hit the nail right on the head. I think having that list of kind of prescriptive paths and strategies would be immensely helpful as folks start into these projects with different project types. So that would be a major key in overcoming any of the challenges that we faced as a design team initially. So it sounds like we're moving in that direction quite quickly. So thank you for that.
Thanks, Keon, and for the feedback also. So let's move into kind of our last discussion topic here, which is the key benefits of meeting SB 2030. So Pat, as a program implementer, how would you outline the key benefits of meeting the SB 2030 energy standard?
So to broadly describe SB 2030 and to take kind of a step back and maybe look a little bit forward in the program, this mission of the program is documenting that you're hitting these increasingly stringent energy targets, right? But you're doing so in an alignment with what those cost-effective options for your specific project are. So it is taking this lofty goal of rationing towards net zero in 2030 and operationalizing it with an understanding about what the opportunities are on each site. And in doing so, and again, at this kind of 30,000 foot level, we're looking at the 2030 program as providing efficiency and bringing on additional energy generation resources that increasingly match the building demand that's being brought online. So moving to, instead of hopping immediately to net, ratcheting towards that by matching those two things and moving towards a balance of those, so that when projects are coming through our program in 2030, program updates aside, it's going to look a lot similar, where I'm anticipating to look similar to now, where you're bringing on these resources at the same time that you're bringing on the new building. So matching those two elements. So yeah, you're essentially asking those the project development to take increasing responsibility for the demand of their additional development. Like, yeah, from the sky, look at what we're doing here and what project teams can achieve.
Thanks, Pat. And Kris, how about from the perspective of a utility-sponsored efficiency program?
Sure. As the community strives to build more sustainable buildings with a lower carbon footprint, the SB 2030 program delivers the framework to achieve those goals. And as such, the EDA program uses the SB 2030 as a potential baseline for all projects, not just those pursuing the SB 2030 program, as we find it's a valuable benchmark to compare results and give participants a reference point to target, at least something to strive for. So in each of the projects, we provide a chart similar to this, showing them how their bundles match up to what the SB 2030 requirements would be. And projects participating in SB 2030 also find this comparison very valuable because it clearly documents what the goals are and helps ensures that the bundle of measures they choose will meet the goal.
Thanks, Kris. And Keon, from your perspective as the architect, has participation in the SB 2030 program helped to push the design for Marshall Avenue flats to greater levels of energy efficiency? And if yes, how?
Yeah, absolutely, absolutely. I think certainly on this project, it has helped to push the limits. I think oftentimes, design constraints, if you will, end up being opportunities to overcome challenges that we all need to face, as a society. I think from the perspective of the Architecture 2030, I think, we all know what we're facing. And I think that this project was able to actually turn these goals into a benefit for the developer ultimately. So I think it's great when we are able to look at these things and push the designs in a way that allows us to reduce the overall carbon footprint as we march towards that 100% EUI reduction and all that. And I think, we're starting to get to a point, particularly as I look out the window and see the haze of smoke in our current environment, where we're really starting to collectively see the benefits of these moves beyond, just money and dollars, beyond what we're improving in terms of efficiencies, which, at a certain point are going to kind of cap out, and going beyond that and looking at other renewable options. We've just got to do it as the world grows. Folks are going to need places to live, work, and play, and we have to be good stewards of the environment. So, yes.
Thanks so much, Keon. Do you have any final advice for project teams based on your experience?
Yeah, absolutely. Absolutely. I think my final advice would be just make sure that you are looking at, particularly from the standpoint of kind of from how the process would have worked before 2020 until now, make sure that you quickly dive into that hierarchy of renewables and make sure that you understand what's achievable and attainable. And not just that you understand it from the perspective of what's required, but why it's required, because we all know that as we march towards carbon neutral, there's going to be challenges in terms of making that cost-effective boundary work on certain certain project types. And that's what we learned on this one. It's not a matter of trying to push something or force something that's not cost effective, but rather trying to find alternative paths that are kind of built into the process that allow you to achieve that ultimate goal of carbon neutrality to move towards, you know, that higher expectation and higher marks. So I don't know if that made sense, but thanks.
Yes, it absolutely did. And thank you so much. And how about from the perspective of the SB 2030, you know, review team and implementer Russ and Pat, can you offer some final advice to those entering into the program?
Russ, again, I'd like to stress, you know, how important is kind of echoing what Keon said, is to think about this early on in the process and, you know, really reach out to Pat and start looking at some of those measures. And one thing that we found is there a number of projects as they're going through, and we've made some suggestions for measures that need to be evaluated just for the sake of, you know, seeing what the cost-effective target is. Oftentimes, those measures have ended up being incorporated into the design and making the project more efficient, and not beyond just being used as part of the goal setting activity for that. Just yes, start early and reach out with questions, because we want these projects to be successful. And the earlier you realize what the challenges are and where your performance is at, the better, more likelihood that you'll have issues and not, you know, dealt with early on and no surprises at the end.
And I think from our perspective, I'd underline everything that Keon and Russ have mentioned about that early engagement with the process, that early understanding about what the balance of efficiency is going to need to be and what the balance of measures that are going to be coming from offsite are going to need to be. I'll note here as well that we've developed this process in part to be able to adapt to market transformation as it occurs. And so what we're seeing right now is how this process overlays on a current set of cost-effective opportunities available for this project team. New technologies emerging on the market continually. We may see different technology coming in within this 12-year window for a project coming online in a couple of years. We may, we're likely to see more of the on-site renewable energy falling within this window. So one thing that we've looked at in our program design is to find a way to, meet those two constraints of hitting these increasingly aggressive targets in order to, offset that carbon, the increased carbon production, and to do so cost effectively, which is the other kind of bound that our program is within, but also that will be nimble in terms of how changing technology that's present in the marketplace that is available for project teams to pursue. So while we will be looking to set those lists of potential strategies for project teams to be able to get to early, those lists will shift as new things emerge. So that's just a note to engage in the process early, and then we are looking to have that assistance and that review front loaded so that we can get a good picture of what the building is going to look like early in the process, and then later in the process it's just a confirmation that we've retained that level of performance.
Great, thank you. Thank you everyone so much for sharing your experience and providing so much valuable information and insight about the SB 2030 program and how utility and energy efficiency programs can support that, and how teams can navigate this, because we all are working towards a common goal. So this does conclude our panel discussion, and now we will move on to the live streaming audience Q&A.